Okay, this is still dealing with section 4.1, and we're going to be looking at some mini proofs, I guess they call them in the book. And all I did here was I made up a few similar to what you would see in the book, and hopefully using the 8 fundamental identities, you'll be able to follow along and understand what I'm doing. So you're looking at page 139, the fundamental identities, excuse me. So one of the best ways to do it is that we want to show that this is equal to this. So what we can do is we can actually work this out or expand this left side out here. So that would be cosine theta times tan theta plus cosine theta. Okay, and that's going to be the left side. Now if I continue on and I take the quotient identity for tan and plug it in there. So if I say cosine theta and put in the quotient identity for tan, which is sine over cos. So replace that in with sine theta over cos theta. Plus cos theta is still out here. So we know that these will cancel out here when we multiply. So this is going to be sine theta plus cos theta. So that is the form that we're looking for. So all we have to do is multiply out and then replace with one of the fundamental identities in a little bit of a mini proof. Okay, we have a couple more here. Okay, so what if I had something that looks like this? Sine squared theta over cos theta plus cos theta is equal to secant theta. Okay, in these types of questions, we're going to be using, again, the basic proofs that we need as well. But it's a mini proof, so if we kind of do the similar operation here, do an addition, but we have to get a common denominator. So if we put that one over 1, we can actually say to ourselves, well, let's put it all over cosine. Cosine theta. Okay, that's going to be our common denominator. Well, if you look at this one has sine squared theta already. Okay, and that's already got the cos there, so there's nothing we need to multiply by except by 1, which means it's the same. But if we want to change cos theta into something over cos theta, we have to multiply it by what's missing. It's got cos theta over 1. It's missing the cos theta, so we go cos theta times cos theta. Okay, if we look at that, that's sine squared theta plus cos squared theta over cosine theta. Okay, well, if we look at the Pythagorean identity, sine squared plus cos squared theta is equal to 1 by one of the Pythagorean. Okay, so that's what we use there. And this one here would be a reciprocal. We'd use a reciprocal identity. We know that 1 over cosine is actually equal to secant. So the left side is now equal to the right side. One more mini proof to look at in this area. Let me move this up, make sure it's still in the field of view. And then we'll actually go into the next section, which is actually doing 2-column proofs and a little more complex type ones. If we look at this one, we want to prove or show that 1 plus 2 tan squared theta equals tan, or plus, not equals, plus tan to the 4th theta is equal to secant to the 4th theta. Okay, so we're going to be looking at this one and thinking to ourselves, well, one way to actually do this is to think to ourselves, well, if we want to look at this here, and we could probably break this down into or we could convert this one into a certain form based on what we know of the Pythagorean identities here. So simply put, we can say that this form can be factored. So that'd be like saying 1 plus tan squared theta times it's 1 plus tan squared theta. Okay, so that we factored this here left side into this. Okay, so if we could factor that into this, okay, we now have a simple fact that this is going to equal secant to the 4th theta. Okay, so in our problem here, once we get to this point, we can say that, well, what does 1 plus tan squared equal in an identity? So we look at our Pythagorean identities, and lo and behold, that's secant squared. So each of these represents secant squared theta by the Pythagorean identity. Okay. Once we've done that, we simply multiply them back together to get back to here. And that's, secant to the 4th theta. And then again, we can see that this side and this side are equal. So what we did was we factored it, and then we were able to see that each of these represented a Pythagorean identity, and then we were to multiply it back together to get it back into that form. Okay, in our next tutorial, we'll be looking at some proofs, some actual proofs.